Hello everyone, great to having you. So I will try for the next 30 minutes to give you a good understanding both on the use cases and the technical details of our next Ethernet fusion technology, Ethernet fabric technology named Junos Fusion for data center. I think it's a very exciting product, and especially in the IT space, it's actually a very challenging time for the IT enterprise guy because it's evolving so fast. I mean, there are most of them still managing the network in a traditional way, and they are extremely concerned about how we can help them to reduce the complexity, reduce all their OPEX and the management cost, and often the outages associated with those challenges. And at the same time, they all want to evolve with more an IT as a service type of infrastructures, more driven by overlay, automation, and all these kind of things. And I mean, managing their day-to-day challenge and moving to where they want to go tomorrow is definitely a challenge. And we'll build these solutions to really help them with that, help them to start where they are and evolve there to SDN, to IT as a service, to an NSX or OpenStack integration. So I will walk you through that. So the first part that is really important for us is the simplified all the aspects of the operation. Simplify the management, so that's a solution that will provide a single point of management for and a single point of configuration for the operator, and as well provide the single point of the troubleshooting or all where you get all the current state of the networks. So that's extremely important. And we put a lot of efforts to put the deployment of new racks or new services completely plug and play. So all this part is taken care of. If you know a bit of Juniper history, you know that's something we've been focusing for a while. I mean, Bruno told you that we got into the switching business in 2008, and since 2008, we did put a lot of efforts to address those 3 points and make our switching solution extremely simple. I mean, we started with VC, which was one of the really most robust stacking technology at the time, and then we had other technology like VCF or QFabric. It has always been a concern for us, and this one is really in this going into the same direction, but each time we are trying to learn from the feedback we got from our customers and do even better. And I'll try to explain you actually what we did differently this time and what are the feedback we integrated and why we did that differently. One thing I'd like to point is even if you are trying to move to complete automation and IT as a service, having a single point of management is actually very interesting, because you don't have to integrate, for example, each time you put a new rack, each time you put a new services, you don't have to integrate this part to your orchestration platform. You can just do the integration once at the initial deployment, and then all this part underneath is automatically will be available and will be something you can leverage through any type of orchestration layer. So it's really, we do support all kind of management, and we know that we have all kind of customers, so it's really, we are committed to support all of them, and we don't want to force you to go in either way. So we do provide, for example, Network Director as a Juniper solutions, nice GUI, no flash, to manage the solutions, or you can go to the CLI. You can use all the APIs. I mean, APIs have been at the heart of Juniper since day one, with either Netconf or now REST API. We're moving toward Yang and OpenConfig. That's definitely an option, but also OpenStack through the different plugin or through all the orchestrations layer like OpenControl or NSX. We are making sure that we have the OVSDB integration and all these kind of things. So what are we doing differently this time? And if you look back, actually, each time and it's not just us actually in the industry, every time we try to simplify the management from a user point of view, like providing a single point of configuration, a single point of CLI, we often had to create a single system overall. I mean, and all the components, all the parts had very tight dependency and tightly integrated as we name them together. Think of a chassis, for example. I mean, the chassis, you have two routing engine, master, backup, and the line cards, but you never ask to have one line card running a different version than the other. And that's actually not possible because how the chassis is built is everything is seen as one, even though it's modular. In this system, and when we're building large fabric, we know that customer has for most flexibility. That's actually been the main ask we got from customer for years is, I want to be able to use and see all my components in my data center in an individual way. I want to be able to upgrade my top-of-rack switches without upgrading the next rack. The same way I will do it if I have an IP fabric. But I want that plus the benefit of the central management, central operation, and that's a very, very, very big challenge. So we completely rethink all the architectures, and we are actually now leveraging what we name an open protocol-driven infrastructure. So we are seeing all the components are independent, and they are all capable technically to evolve independently in terms of software, in terms of features, and we have protocol underneath that will take care of this complexity for. So one features I really like, and that's really, as I said, the one that people have been asking most, is that technically the infrastructure lets you put any versions anywhere on the system, and there is no. Of course, we'll have like some compatibility metrics and validation limitation, but the infrastructure in itself lets you work with, for example, two top-of-rack running two completely different versions and have a server that is actively attached in an active way to those two top-of-rack at the same time. And it will let you, for example, if tomorrow we'll decide to have a new access switches, we will be able to plug it in. Even though the day you deploy this infrastructure, this switch was not even available, or we don't even knew it was existing, just because the protocol will let you do that. The upgrade path, the downgrade path, everything is completely flexible. That's really some of the benefits we got from this protocol-driven infrastructure. The other benefits that's, from my point of view, extremely important is if you look at all the solutions around, usually each time we try to simplify the management, we actually had an underneath limitation that all the components have to run the similar type of functionality. And for us, for example, all our VC, VCF, QFabric, had to have a Broadcom type of solutions everywhere, and Broadcom is very good for top-of-rack because it's a lot of throughput, latency, but has, as we know, it has some limitation in scaling, it has some limitation in features. And with this, again, open protocol-driven infrastructures, we're able to bring very different type of system with an aggregation device like the QFX 10000 that has high buffer, high logical scale, all the MPLS, the routing capabilities, and combine that with very high throughput, low latency, power efficient top-of-rack. That's really one of the first time that we're able to put both of them together and get the better of the best of both worlds. That's a very important step. One of the features, for example, that enable is this, what we name at Juniper, the universal SDN Gateway. These capabilities to speak, for example, VXLAN in one direction, MPLS on the other one, and be able to be the tunnel termination endpoint for multiple type of tunnel and stitch them together. We know that moving forward and that the overlay will stay in the data center and that's just the fact. I mean, no one see those type of overlay moving away. So we have to propose propose some solutions to integrate all that correctly with the one internally and with the legacy infrastructure. And even though we know that some of the merchant silicon, for example, will get those routing capabilities, that's nothing to compare to what the Juniper silicon can do in terms of tunnel stitching. So very, very important part. If we look a little bit at the hardware, so the aggregation device for the Junos Fusion for data centers are the QFX 10000 series, and at the access devices, we are reusing some of the existing hardware we have, so the QFX 5100 or the EX4300. But you will notice that those devices actually don't run Junos. We reuse exactly the same hardware platform, but we are using a very light version of Linux because all the management is centralized. Everything in terms of a lot of operational stats are centralized on the aggregation device. We didn't have the need to put Junos and with all the features and those capabilities. So Junos remain on the aggregation device, but we have and we make sure that the conversion from the standalone to the Junos Fusion Access devices is done seamlessly and in an automated way for a customer. Any questions so far?
Yes, the lightweight device. Say more about that. I mean, how light is it? What do you really just not need to interface with those devices anymore? And so therefore you're running something that's more or less an agent for central control to deal with?
Basically, we are using the same, earlier Doug presented the QFX 10000, and it's actually the same architecture on the 5100. We now have a Wind River yoked to Linux, and on top of it we put Junos in KVM. Here what we have is we keep Wind River yoked to Linux, and we now just have a process that's actually doing the control plane integration, and that will push the information to the hardware. So that's what we have.
So basically an agent then?
Basically an agent, yeah.
A truly dumb switch.
What is very interesting as well is we make sure to build an active system, and so there is absolutely no concept of master backup in this system, neither for the management of the traffic, and I will go back to that a little later, but even for the management of the device. For example, I think the access devices, they are completely managed in an active way. And how it works is either of having a synchronization of all the state of these guys between those two and have to replicate. What we did is we just maintain two connections, for example, from the access device to the aggregation device, and the access device, which has really very powerful CPU, is just sending twice the information and making sure from the access device to synchronize the information. That removes a lot of complexity and need for synchronization between the aggregation devices. Now that we have an extremely powerful top of rack, we want to make sure as well that we leverage as much as possible the capabilities of this top of rack. So we have a lot of plans to put as much as features as we can on access device, but we are also supporting a mode where everything is all the traffic is centralized, and there are actually a lot of benefits to that, and especially when you have a very powerful device, like for a customer that is looking for the buffers or the logical scale, then you can have a lot of all the traffic centralized. And we know that for not all of our customers are concerned about the latency of the throughput. Some of them, they know that having all the traffic centralized is okay. But on the other side, we know that we have customers that are really, for them, it's really, really important to have high throughput, low latency. And for those customers, we're also proposing local switching for all the layer 2 traffic. And in the future, we're looking at a layer 3 traffic as well. So I've been talking on, let's say we have protocol-driven infrastructures. Let me give you an idea of what are those protocols. So if you look internally, between the aggregation and the access devising, we are using mainly 3 protocols. The first one is LLDP, and we use that for everything related to auto discovery, auto provisioning, and we plug and play system for the access devices. For everything data plane related, traffic related, we use an extended version of 822.1 BR. between the access device and the aggregation device. And for everything non-traffic related, like the management of the hardware, the FRUs, the PSUs, we have our own JSON RPC APIs underneath between the aggregation device and the satellite and the access devices. Between the two aggregation devices, we use two protocols, mainly netconf for all the simplification of the configuration. That's really our protocol of choice at Juniper every time it comes to automation. And we use another protocol named ICCP for the synchronization of the lag and all the layer 2 information. And ICCP is a very well-known protocol at Juniper because it's the protocol that run MC-lag, which is a feature that have been around for years. So it's a very robust protocol that we just reuse and leverage. And often the feedback we got from customers that MC-lag is great, but it has some challenge in the management part. And that here we reuse that, but we completely hide all the management complexity, and to bring those benefits. So now I'd like to give you an idea of how it will look like from an operator point of view, and how to operate. So first, all the access devices will get assigned an FPC ID. And same as so an FPC for Juniper, it's basically in a chassis, each line card get an FPC ID. So it will really looks like from the aggregation device, the ports will appear as if they were local. If you do show interface, it will show all the ports that are in the aggregation, as well as the port that are on the access devices, and they will just get a name that indicate that they're actually remote. And for a port that is on FPC1, FPC 101, this port will be available on either aggregation device, and you will be able to see the states, to be able to configure it on any of those aggregation device. As I say, in terms of configuration, so the configuration is completely, the part that matter is completely synchronized between those two devices. So you can go on any of those aggregation devices and build your configuration, and the system underneath will make sure to synchronize that to the other one, so you don't have to do that manually. Great.
So on the aggregation devices, they have their own locally significant ports, like the 002 on the example there.
Yeah.
And then the config for the access is the same on both.
Exactly. So that was my next point, is because the aggregation device, one interesting point is they're actually completely independent. And Junos Fusion is something that you turn on per port. It's not a technology that you just enable on the system and that will bring down your capabilities. You keep your aggregation device, and on a per port basis, you will say, I want these ports to turn and be in a Junos Fusion mode, and then it will accept to have satellite connected. So everything that is synchronized only concerns the part that is turned into Junos Fusion mode. Everything else, as you mentioned here, the external port will remain independent and will not be synchronized. And that's actually, we see that as a plus, because it makes it easier to integrate with your existing infrastructures, your existing architectures, that you will have exactly the same type of layer 3 interconnections upstream with the core, with the one that you have today. It's not as seen as a single entity for the routing, and we rely on the layer 3 routing to provide redundancy. Any question? So all the states, all the statistics, everything is centralized on the aggregation device and is available on both aggregation devices. So you never have to really connect to the SS device. All the image management, upgrades, everything is done on the aggregation device, either of them. You can connect to the access device, but it's really like for very low-level troubleshooting that you should never have to do that.
And in terms of scale, how many leaves can you connect to its spine?
So initially we were looking at 64 leaves, and our plan is to increase to 128 access devices. If we have the needs to have more than that, the feedback we got from customers that usually people don't try to have like a too big pod, and they will rather start building multiple medium-sized pod and interconnect them if needed. And now that we have those aggregation device, we can turn in, for example, technology like EVPN VXLAN, the one that Dagangs introduced earlier, and we'll be able to have some layer 2 stitching across multiple pod, 2, 3, 4, 5, and still have completely distributed default gateway across all those pods for the same layer 2 domain. So there is no tromboning, there is no complexity associated with that. That's all the benefits to have those rich features devices at the aggregation device.
So in the architecture, you are still limited to it's 2 spines, effectively, right? That's the design.
Yes.
Okay.
So today the architecture is limited at 2 spine. It has a downside in the blast radius, but when we look at it, it doesn't limit neither the throughput or the oversubscription you can provide, because if you take, for example, a 10,008 as an aggregation device, you can have up to 240, 100 gig port on a single device. If you take the bigger one, you can have a 480 port, 100 gig port on a single device. So you have plenty of available ports for the oversubscriptions, and make sure you could even run at almost one-to-one oversubscriptions on your leaf. But yeah, the two aggregation device.
Right, and the link between the 2 spines is that's drawn there. Is that for syncing? Is that for actually for traffic as well? I'm assuming that the sync is happening on the production side, not on the management side. But
no. So the syncing is actually for mainly control plane, and also to take care of a failure scenario. Like if you lost one link between one aggregation device and an access device, then it will become the backup link, the backup path to still be able to reach a specific access devices. So we usually try to provision that as like twice the size of an aggregation to access device link.